Hey everyone, welcome back to the channel. I hope you guys are doing really well. So we will see today's daily challenge on Leetcode and we will also solve it together. So let's see the problem. Minimum time to make rope colorful. Alice has n balloons arranged on a rope. You are given a zero index string colors where colors of I is the color of the ith balloon. Okay, and Alice wants the rope to be colorful. She does not want two consecutive balloons to be of the same color. So she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You are given a zero index integer array needed time when needed time of I is the time in seconds that Bob needs to remove the ith balloon from the rope. So we need to return the minimum time that Bob needs to make the rope colorful. So you see in this example, there are two consecutive blue balloons. So what does colorful means is that there should be no balloons which are consecutively of the same color. So you want to remove any of this balloon. Now the time required to remove the third balloon, as in this problem, is 3. The time needed to remove the fourth balloon is 4. So you need the minimum time. So you need to remove the third balloon, and you see no balloon is right now consecutively of the same color. It's blue, red, blue, green. So yeah, no balloon is consecutively of the same color, and yeah, you have achieved your job by removing one balloon, and you took three units of time for that. So yeah, that's what you need to output. What is the minimum time you will take? So you see, if all of them are not of consecutive same colors, none of them are same colors in consecutive manner, so you can just remove none of them, so zero time. If you look at this problem, the time needed to remove the first and the last balloon is 1 and 1, which is minimum. Okay, and you see they have a consecutive balloons, the first and second, and the last and second last, right? So you need to remove one from both of these clumps. Okay, so you see, you just remove the first and the last one. You will be requiring only 1 plus 1 2 amount of time, and you have your answer too with that. Okay, so that's how you need to solve the problem. And the thing is that the main thing in this problem is that you need to know some additional information which is actually not given in the question, so it should be given more clearly. So let's say you are having some balloons. Let's say this is a balloon. Okay, this is two consecutive balloons, right? Now this is, let's say, three consecutive balloons, or let's say four. Okay, and so this is another, and this is another. Okay, so you need to remove some of the balloons. So you see, what do you need to do is that from these two balloons you need to remove one of them. Okay, now whichever is the minimum, obviously you will remove that. Now from these four balloons you need to remove three of them. That is what you need to know, because you see, why three of them? Because if you, even if you, let's say you have three balloons, right? Even if you remove the middle one, these two balloons comes consecutive right now. Okay, so you need to remove n minus 1 balloon. So in a cluster, so basically what I hope now you get some idea of how to solve the problem actually. And you see, these are single colored balloons, so you do not need to remove them at all. So you need to remove here one balloon, and here three balloons, a total of four balloons you need to remove, and you will definitely select the ones with the minimum. Okay, so I hope you get an idea that uh, we need to divide our array into clusters of same colors. Okay, we need to divide our array into clusters of same colors of balloons. Now, if a balloon consists of if a cluster consists of n balloons, you need to remove n minus 1 of them. So let's say n is here 4. So you remove n minus 1, which is 3. Okay, so you remove out of a cluster of n balloons, you just remove n minus 1 of them. Okay, and you will be remaining with 3 balloons. So yeah, that's what you need to do. And definitely, you see, you need to have the minimum uh, time, right? So what you can do is that, let's say this balloon takes up 5 amount of time. This balloon takes up 2, this balloon takes up 7, this balloon takes up 3. Okay, so which are the balloons which you are going to remove? You should remove 2, 5 and 3. This 5, 2 and 3, right? 5 plus 2 plus 3. and you should leave out the one with the maximum because you need the minimum time, right? So you need to leave out the one with the maximum, and this is 10. So I hope that is very clear. Now how you can achieve this? You can keep a running sum. So as you are iterating, let's say you are having I equals to 0 here, and as you are going through, you should traverse only once throughout the array, right? You should try to traverse at least only once, okay? And when you see, you keep an account of the maximum value in a particular cluster. Okay, so maximum value in a particular cluster. You see what is the, when you change a cluster, when you are going to change a cluster, you will see that what was my maximum value in this cluster. So the maximum value was nothing but 7. What is my, and also you take an account of the sum. Okay, so what was my sum? It was 5 plus 2 plus 7 plus 3, which is nothing but 17. Okay, so out of this 17, my sum, out of this 17 sum, my maximum is 7. Okay, so if I want to leave out my maximum, I should add s minus maximum, which is nothing but 17 minus 7, which is nothing but 10. Okay, so in this way also, instead of adding all the 5 plus 2 plus 3, you can directly subtract from sum. You can subtract the maximum value from sum and get your answer as 10, and you can do this from every cluster. Okay, now you need to also take care of that. If a cluster has only one balloon, so if cluster size, so I can just tell that if cluster size has only one balloon, then do not remove any at all. Okay, so you do not need to remove anyone. And if it has at least two balloons, and at most any of them, you need to remove size minus one number of balloons. Okay, so cluster size minus one. So I hope that is very simple for you, and I will now tell you to actually pause the video. Okay, and if you have understood, then try to solve it on your own. And if you were able to solve, you definitely write in the comments that yeah, even without watching the video, just hearing the explanation, I was able to solve. Yeah, otherwise you can also continue watching the video to my solution. Okay, and now I hope things will be very simple. So what are all the stuffs I need? I need an answer initialized to 0. Okay, I need a running maximum and min and sum. Okay, so my running sum will be, let's say, time of 0 because I start with the first element. I start with the second element, let's say, and my maximum value is also at the, let's say, first element. Okay, so what I can do is that I can start from the second element. You can see I equals to 1, and I can go for time dot size I plus plus. Okay, now I will check that if this colors of I is not equals to colors of I minus 1, it means that what does it mean? It means that if this is, I mean, colors of I hope you do understand, right? This is the colors of I and this is I minus 1. If they are not equal, it means that we are on a boundary and we are changing segment right now. Okay, so if we are changing segment, what are the things we need to do? We need to update our sum and maximum. So definitely I will do something like s equals to time of I and max equals to time of I updated my sum and this value. Okay, and what I can do is that I also need to update my answer, right? So answer will be plus equals to, as I told you, s minus maximum. Now, do we need to do this always? No, right? We need to do only in cases where the cluster size is greater than 1. If it is equals to 1, we do not need to remove that balloon, right? So how will we ensure the cluster size is greater than 1? So I can keep a boolean variable another 5 0. Okay, so this will act as a boolean variable, and when will it go in the else statement? It will go in the else statement when there are at least two balloons. So if two balloons of the same color, so if consecutive colors are not equal, it will go in this if statement. And if consecutive colors are equal, meaning that if there are at least two balloons, okay, then f will be set to 1. Then what we can do, we can update our maximum value. We will update it in this way, and we can also add something to our sum. Okay, we maintain, but instead of this, as I told you, instead of this adding this answer every time, I need to add it only when f is true. Okay, so if f is 1, because that is the time when it has more than one outputs. Okay, and you see, if you take account of the last running segment, that also you need to do, right? Because you see, let's say you had this cluster, and an array at the end also has a cluster. Okay, so let's say this was a red, and whole all of them were belonging to red, and you did not change any cluster, you just ended the array. So while changing the cluster, you were updating the status of this cluster. While changing this cluster, you were updating the status of this cluster, but you were not changing the last cluster at all. So for the last cluster, you just add things to your answer. Okay, add the s minus x sum to your answer, and you can just simply return answer. I hope this was very clear to you and not at all difficult to understand. And yeah, this is a simple problem. You can just try to submit it. You see, you get the accepted thing easily, and you try to run it for all test cases. I hope it will just work fine. But yeah, runtime is not much good, but it varies a lot. I can show you with the same code I had got a much better. Actually, with the same code I had got 100% runtime bits. So let me run it once again. You see, with the same code I am getting 14% as well as 100% runtime bits, as well as memory is also quite good. And you can see time complexity is O of n. And yeah, that's all I guess. Uh, that's all for this video. I hope you did get the solution. I will meet you in the next video. Till then, thanks a lot.